Hey, this is the second recording on this because I got more than halfway through the set and discovered a typo in the problems. So hopefully we have fixed that. This is our practice set on solving quadratics by factoring. Please like and subscribe for more math content. Drop a comment or a question below to engage, and check out the other videos on our quadratics playlist if you need refreshers on how to solve quadratics other ways, or what they are, or factoring practice, or whatever you might need. As always, pause the video to work these problems on your own and then come back to check your work. All right, so we're basically going to work through this. It'll probably be a longer video because I'm going to explain the steps as I go through them and kind of point out a few things to you. I'll try to pick up the pace from my first recording. It's gotten very dark. It's been thundering here for a while. Not raining too much, but it's been grumbly. Okay, so first thing we need to do is when we're solving a quadratic by factoring is we need to set it equal to 0 because we're going to engage that zero product property. In these first two problems, we'll notice that we already have a 0, so we don't have to do that first step, which means we can go right to our factoring. Now, you can put your factoring work into the body of your problem, meaning you could set up your area model and then set up your factors underneath it. Typically, though, when I'm solving a quadratic, I'm going to put my actual factoring scratch work off to the side. So for this first one, I'm going to come over here and put it off to the side. So we have x squared and negative 12. And so 1 times negative 12 is negative 12. And I'm looking for two factors of negative 12 that add up to the middle term, which is a positive 4. And so I have 1 times 12, 2 times 6, and 3 times 4 are my candidates. 2 times 6 is the candidate I want. If I want it to add up to positive 4, the 2 would have to be negative. Quick check, okay? I did this in the practice video I recorded yesterday. Just over and over and again, double check it before you put it into the little boxes, okay? Negative 2 times 6 is negative 12. Negative 2 plus 6 is positive 4. So this will be negative 2x and 6x. Greatest common factor between x squared and 6x is x. X times x is x squared. Negative 2 times x is negative 2, and 6 times x is 6x, and 6 times negative 2 is negative 12. Now, instead of writing the factors underneath it, though, I'm going to come back over here and write x minus 2x plus 6. Now, from here, there's I'm pretty much every teacher is going to want to see your factors. Okay, they're going to want to see that you have the correct factors. If you jump straight to the answer, that's going to raise all kinds of red flags. Okay, but from here, what I would do is simply say x equals 2, x equals negative 6. Okay, because I've done this a million times. What you might need to show, though, especially when you're first doing this, your teacher might want to see your application of the zero product property. Meaning, if you have two factors multiplied together, that's multiplication right there, and the product is 0, that either the first factor or the second factor has to be equal to 0, and they'll want to see that written out to make sure that you understand like the zero product property. Now, the next step, which is the algebra step, the plus 2 to both sides or minus 6 to both sides, that's how we eventually end up with the answer. Negative 2 plus 2 is 0, 0 plus 2 is 2, therefore x is equal to 2, and same reasoning over here. This step here, I know there are teachers where I work that do not want to see that. They will actually get upset if you show that. So I tell my students, it's not algebraically wrong. If it helps you to see it so that you know what you're doing on both sides of the equal sign, that's fine with me, but it's certainly not required. Okay, it's definitely not a required step. So if you see x minus 2 equals 0 and you can tell me that x is equal to 2 because you're going to add 2 to both sides, go for it. Now, the other way you might show your work here is to put the factoring work into the body of the problem. So we've got no common factors here because 2 and 5 are prime numbers and they're not the same prime number. So we have 2x squared and 5. We're going to do 2 times 5 to get 10. And then we want two factors of 10 that will add up to an 11. which would be 1 times 10, and it's got to add up to -11, so they would have to be -1 and -10. Gonna double check that. -1 times -10 is +10. -1 plus -10 is -11. So we have -10x, -1x. And when I factor, I try to avoid as many common factors as I possibly can. So when I'm looking at like the different ways I could GCF factor, I try to look for what's the one that I can do the fastest. So 2x squared and -1x, the GCF is x. So I'm going to factor in that direction first. That means 2x times x is 2x squared. This will be -1, -1 times x, and this will be a -5. And you can double check that. You can double check all your boxes. So 2x times -5 is -10x. -1 times -5 is +5. And then we can go ahead and put in our base and our height. And once again, I can go straight to that. All right. I can also go straight to this. Okay, I've done this for like really a long time. I'm older than I want to admit. So I can do that. I don't think anybody's going to question that I knew what I was doing. But if you are an Algebra 1 student specifically, less so if you're watching this video as an Algebra 2 student or a pre-cal student. But if you're Algebra 1 student and this is like your first go around with this, it is highly likely that your teacher is going to want to see that. You're probably okay skipping there, but on this side, probably your teacher would want to see that step as well, for adding the 1 to both sides. And then you would, most people will show the division, and that's where the 1/2 comes from. So you would add 1 to both sides and then divide both sides by 2, and you'll get the x is equal to 1/2. Which one of these is better? Like just going this way with scratch work off to wherever you put your scratch work, or whether the teacher would like to see your work for the factoring in the body of the problem, follow your teacher's directions. Okay, so we've got a couple here that are not equal to 0. And I'm going to show you again how you can skip some steps or what might be acceptable. So I'm doing this problem. I'm going straight here. Okay, that's like my next line down, just x squared minus 7x plus 12. Here's what I did to get there, okay, because we never want to copy work blindly. I subtracted 7x from both sides. So on my left, that gives me x squared minus 7x. 7x minus 7x is 0, and so that drops out on the right. And then I'm going to add 12 to both sides. And so that means my right-hand side is left-hand side is x squared minus 7x plus 12. Over here, -12 plus 12 is 0, and so everything on the right cancels out. I'm going to go ahead and put my factoring work off to the side. Okay, so I've got x squared and 12. There's like so many 12s in today's problems. I don't know why that's the case. It's just the number comes up a lot. I guess it does come up a lot because of there's so many factors to it. 1 times 12 is 12, and our combinations of factors of 1 times 12, 2 times 6, and 3 times 4. We want the combination that's going to add up to -7. Got to remember where you are on the page over there. And that means both of them have to be negative. Quick double check. -3 times -4 is +12. -3 plus -4 is -7. So in my boxes, we've got -3x and -7x. GCF of x squared and -3x is x. X times x is x squared. We get the -3, -4. -3 times -4 is +12. Coming over here, this is where we're going to write the factors. X minus 3 and x minus 4. And again, if you're comfortable with this, especially if you're in an upper level class, so you've cleared your Algebra 1, you're now in Algebra 2, absolutely you can go straight to x equals 3, x equals 4. If you are required to do so, or you're newer, you're going to show that zero product property step, that if the product is 0, one of those factors has to be a 0. Okay, so you're going to show where that 3 is coming from and where that 4 is coming from. Next one, 3x squared plus 4 equals -8x. And I'm skipping right to this. 3x squared plus 8x plus 4 equals 0. Wondering, how did she do that? What did she do? I added 8x to both sides. But when I added it into the middle because I knew that's where I needed it to go. I wanted it to go x squared, x constant. Okay, so 3x squared plus 8x plus 4. So that's what I did. You might be required to show the plus 8x to demonstrate that you know how you get it in this form. Now, no GCF here, so not factoring anything out. But we got to do a little factoring work. The good news is that we're going to end up with the number 12 again, at this time with the 3 times 4. So 3 times 4 is 12, and we've got that same collection of factors. And something that you might want to notice, especially if it took you a long time to do this, notice how often the number 12 is coming up. And when I wrote these, I did not write the problems thinking like, let's make the 2 come up, the 12 come up a lot. The numbers that we used to factor with only get so big. I mean, you get an occasional like really nasty problem, but you see the same numbers over and over and over again. And so if you have to factor the 12 and you have to keep doing it over and over again, you're going to get so fast at it. And eventually you're going to say, what number do I need to come up with? I need to come up with an 8. I know what that is. That's the 2 and the 6. And you will get really, really fast with it. And that is the goal. 2 times 6 is 12. 2 plus 6 is 8. So I know I have the right one. And I'm going to factor it this way because fewer common factors. GCF going that way is x. X times 3x would give me the 3x squared. X times 2 gives me 2x. And 3x times 2 gives me 6x. And 2 times 2 gives me 4. So that looks good. We have the 3x plus 2 and x plus 2. Now, this one I can do in my head, again, because I have done a million of these, and I can go straight to this. Okay, x is -2/3 and x is -2. What I don't want anyone doing, and what I see my students do on occasion, is they start to look for patterns instead of just thinking through the algebra. In my head, I don't have a pattern memorized of flip the sign, this number's on the top, this number's on the bottom. Flip the sign, this number's on the top, this number. Like, I'm not doing that. Okay, that's not what's happening in my head. And if you try to memorize stuff like that, you will eventually forget it. Here's what's happening in my head. Okay, and the reason I don't have to write it down is because I've done it so much. I am going, this has to be equal to 0. I'm going to subtract 2 from both sides. That's why you flip the sign. You flip the sign because you're going to do the opposite operation. Then you're going to end up dividing by whatever the coefficient is, which means that the coefficient, the 3, is going to end up in your denominator. And will it come out like that every single time? Yep. But what needs to go on in your head is that process, not put this number in this spot, because you will forget that. Okay. And here we've got, of course, the -2. We've talked about that. So no memorizing positions of numbers. If there's a lesson coming up where you do need to memorize like the positioning of a number, I would be open about that and say this is a fact that you just need to have memorized. Not this one, though. Okay, like those numbers end up where they are for a reason. Now, the next one is pretty cool. This one you might have looked at. I'm going to do a little box down here. And thought to yourself, we've done that before. Why, yes, this is one of the few kinds of quadratic equations that you can solve using square roots. When you don't have a b term, when there's no x in it, okay? So you got an x squared and you have a constant. You can solve this using a square root. The thing you have to remember, though, is that there are actually 2 numbers that when you square it will give you the 25. Okay, 2 numbers that when you square it, so you take the square root of x squared, you get x, but it's actually a positive and a -5. So the square root of 25 is 5. The positive and the negative will work because 5 times 5 would give you 25, but also -5 times -5 would give you the 25. So you want to indicate that it is both of those answers with the plus minus. Kind of an easy thing to forget. You can try not to forget it. But the directions for this one, did not say solve by the method of your choice. And probably the next video that I record is going to be something like that, like 10 problems, solve by the method of your choice. Or we might do another strategy first, just for funsies to do another one. But this one we are told to solve by factoring. And the first step for solving it by factoring is to set it equal to 0. So we've got x squared minus 25 is equal to 0. At this point, we need to recognize that is what we call a special case. So we would not use the area model for this, although you could. Okay, but we get the x squared from x times x. We get the 25 from 5 times 5. One is a plus and one is a minus. If you wanted to use the area model, okay, it kind of goes like this, where you need these to add up to 0x. And so you would factor the 25, and you would realize the only way you could get the 25 is with a plus 5 and a minus 5, which is exactly what we've got over there. And it always comes out that way when it's the difference of squares. So we just spare ourselves having to do that. Zero product property. If two things multiplied together give us 0, then one of those factors has to be equal to 0. We'll subtract 5 on the first one. We'll add 5 on the second one. And lo and behold, we get the same answer. When you do this with a square root, you do end up with that funky plus or minus, just indicating that both of those numbers are answers. You'll get that if you use the quadratic formula as well. And but if you do factoring, they're each going to dump out of a separate factor. And so you'll see them as two separate steps, but it is the same answer. All right, this one. Oh, the joy. Okay. So we need to start by getting this set equal to 0. And this one I actually am going to do out in a couple of steps. I'm not going to do this all at once. I could. Okay, like I can do it in my head, but I won't because it's a little bit more. I need to get this 4x over there. So that's a negative 4x. I'm going to get there by adding 4x to both sides. And I need to make sure I add the like terms there. So 2x plus 4x. I got to line that up with the other x's. And I was thinking a step ahead. And now I'll go ahead and subtract the 36 from both sides. So 2x squared plus 6x minus 36 is equal to 0. I can do that in one step. You are free to do that in one step as well. Now, here's where stuff can get interesting. I had mentioned in an earlier video when it comes to getting a GCF. Getting the GCF at the beginning will make things so much easier for you. And if you notice that 2, 6, and 36 are all even numbers, so we have a common factor of 2, I'm going to go ahead and get that 2 out. So 2 times x squared would give me 2x squared, 2 times 3 would give me the 6, and 2 times 18 would give me the 36. And now I will factor the much smaller numbers. Okay, so we have the x squared and the negative 18. 1 times negative 18 is negative 18. And my factor pairs are 1 times 18, 2 times 9, and 3 times 6. Again, we see the same numbers over and over and over again. So see, 18 is a common one. I need these to add up to positive 3 so that I can get if the 3 is negative and the 6 is positive. So negative 3 times 6 is negative 18. Negative 3 plus 6 is positive 3. So this will be negative 3x and 6x. GCF, we've done that earlier in this problem set. X squared plus 6x, GCF is x. And we have an x and a negative 3 and a positive 6. And 6 times negative 3 is negative 18. So we have negative x minus 3 and x plus 6. Now, in this case, we actually have 3 factors. We have a 2, we have an x minus 3, and we have an x plus 6. So what I've done in my class before, I've been like, okay, so the first factor could be equal to 0, the second factor could be equal to 0, and the third factor could be equal to 0. But hopefully the moment I wrote this, you crossed your eyes a little bit and said, what the huh? What? 2 isn't equal to 0? No, it's not. And so we can just ignore that. We do not need to write that ever or at all. Adding 3 to both sides here will give me x is equal to 3. Subtracting 6 from both sides here will give me x is equal to -6. Now, suppose you did not get the common factor of 2 out. We're going to hang out on this problem for a little bit, okay? Just supposing you, now that is the best way to do it, but let's just say you're in autopilot mode. We have not seen a GCF yet, and so you didn't even think about looking for a GCF and you missed it. Here's where you end up. So you've got your 2x squared plus 6x minus 36 equals 0. You set up your area model. This time you've got 2x squared and -36, and you're stuck doing that 2 times -36, and you get a -72. And your heart weeps inside, and you said, I thought this person was nice and she wasn't going to give me problems like that. Well, like I didn't, but you went this way anyway. So we are looking for 2 factors of 72 that we can get a 6 from. So we have 1 times 72, that will not work. 2 times 36, nope. Now for the 3, what are we going to do with that 3? I am going to, what are we going to do? 3, that's 12, 3 times 24. Okay, I can show you what I did there, because it might help some of you. 3 times 36, 2 times 36. What I did was this. I just divided the 36 by 3, and that was a 12. 3 times 12. And so then that gave me the 3, and I just multiplied 2 times 12 to get the 24 up there. 4 times, have I gotten anything close to a 6 yet? Nope. So I'm going to do the same thing there. If I've got 3 times 24, that could be 4 times 6, and I'll just pull out the 4. So it's 4 times 18. Still do not have anything where I can get a 6, so I'm loving that. It is not divisible by 5. It is divisible by 6, and it is 6 times 12. And that, I think, is our combination that will give us the 6. And we're not even done yet because we've got what, 8 times 9. 8 times 9 is our last one, but we don't need it. So it's the 6 times 12, and it needs to come out to a positive 6, which means that the 6 here is negative, and we'll do our quick check. -6 times 12 is -72. -6 plus 12 is 6. And so we'll have -6x and positive 12x. Think, I'm going to factor this way to avoid the negatives. GCF here would be 2x. And this would be yeah, we're gonna have an issue, aren't we? 6 -6 and x. Okay. Okay, no, I guess I never do it this way, so I guess we don't have a problem. Well, we sort of have a problem. I guess I mean, here's what I'm looking at that's bothering me, is that these don't represent the GCF between these, and it's because we didn't get the GCF out at the beginning. So I'm looking like, what's the greatest common factor between 12x and 36, and it's not a 6, but that is what we have using the multiplication. So if I check all the boxes, it does work. So 2x times x gives me 2x squared, x times -6 is -6x, 2x times 6 is 12x, and 6 times -6 is -36. So it doesn't work. So so we end up here, 2x minus 6 and x plus 6. Now, this one, we're good. We get the -6. So you say x plus 6 is equal to 0, and then subtract the 6 from both sides, and we're all good. This one, though, notice that the GCF is still there. You could factor a 2 out, okay, and get it simpler. But this one, when you go to do the math out, so we'll add 6 to both sides, and Finally, we divide it out, and notice that we do get the same answer, okay? And there's a reason I parked here for such a long time going over it. One, because you might have done it this way, okay? So if you're like checking your work, like this might be the way you've done it. But I really want you to see how much harder that was. That was a lot harder to get factored because we did not catch the common factor at the beginning. So if nothing else, even if you caught the common factor, like this will be a caution to you. Get the common factor. Get it. Okay. Just don't go there. All right. So we got to get this one equal to 0. So I'm going to start by subtracting 5x from both sides. And this time I'm going to do it in one step. I'm also going to add 2. So I'll have 6x squared. I don't have any x's there, so that'll just be the minus 5x. This is -1 plus 2, though, to get a 1. And then over on the right, that's a 0 because that's what I was trying to do. No GCF. All right, so there's no GCF to get there. Not thrilled with the 6x squared, but that's all right. 6 times 1 is 6, and I need 2 factors of 6 that add up to -5. We got to be careful because both of these would work. So we're going to have to just double check stuff. I can get a -5 if I have a +1 and a -6. I can also get a -5 if I have a -2 and a -3. Be careful. Okay, because 1 plus -6 is -5. -2 plus -3, also -5. So how do we know which one to pick? That's why we double check that multiplication. 1 times -6 is -6. And I want a +6. -2 times -3 does give me the +6. So that's why we always check both of them. GCF going across the top there is 2x, which would make this one 3x. This is -1, and this one is also -1. So I have 2x minus 1 and 3x minus 1 as my factors. Each of those factors could present a potential solution. We will add 1 to both sides. Okay, I added 1. And now a lot of times we will show the division. That doesn't raise as many hackles, but you might just go there and not show the division. So up to you. So we have 1/2 and 1/3. Not too bad. All right. Now for this one is solve the equation by both factoring and the quadratic formula. So this is like more of a comparison contrast. It also is a review of if you, hopefully if you've watched this video series, we've covered the quadratic formula. If you're watching this kind of out of order, you might say, what is the quadratic formula? You know, in that case, just solve it by factoring and your teacher will get to quadratic formula when they get there. But for those of you hanging in, we do need to get the equation equal to 0. Okay, so we're going to go ahead and subtract 5 from sides. And we'll do this with factoring first. So I do not have a GCF there. So I'm going to just set up the factors and do like a little bit of scratch work. So we have a 2x squared and -5. 2 times -5 is -10, and 1 times 10, that's my factor pair that I need. I need the 1 to be negative in order to get the +9. So -1 times 10 is -10, -1 plus 10 is +9. So this will be my -1x and my 10x. GCF going to the left is x. It makes this 2x minus 1. That makes this a 5, and 5 times -1 is -5. So we have 2x minus 1 and x plus 5. 2x minus 1 is equal to 0. X plus 5 is equal to 0. Add 1 to both sides, and then divide both sides by 2. Okay, if you want to show that out, you can, and then this would be subtracting 5. So again, the scratch work in there would be add 1, divide by 2, optional whether you want to show it, or subtract 5. So the answers to this are x is equal to 1/2 and x is equal to -5. And it's pretty clean. I mentioned in the lesson, we're looking for something that is clean here. And we do have a little bit of factoring scratch work off to the side. Some teachers will want to see that. Some teachers will never want you to show it. I'm okay with it just kind of being off to the side to show, like, this is how I came up with these factors. As always, follow your teacher's directions. Now, for the quadratic formula, for the quadratic, spend the day. For the quadratic formula, we need to know that A is equal to 2, B is equal to 9, and C is equal to -5. The quadratic formula is x is equal to the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Okay, and the quadratic formula, we should be able to dump those numbers in, and we've got to just watch our order of operations. So the opposite of B, if B is 9, then the opposite of B is -9, plus or minus the square root of, and I tell my students, always put that B in parentheses, just do it, minus 4 times 2 times -5, all over 2 times 2. Might help you to think of that minus right there as a plus negative. Gotta keep going. -9 plus or minus 9 squared is 81. And then we're going to be doing right here, -4 times 2 times -5. -4 times 2 is -8. -8 times -5 is positive 40. All over 2 times 2, which is 4. 81 plus 40 is, what is it, 120, 121? Right, okay, like 121. Something, it's something. Okay, the square root of 121 is 11. And then the problem splits in two. We're going to have x is equal to -9 plus 11 over 4. And we're going to have x is equal to -9 minus 11 over 4. -9 plus 11 is 2 over 4. And 2 over 4 simplifies to 1/2. -9 minus 11, or if it helps, -9 plus -11 is -20, and -20 divided by 4 is -5. And what you should notice is that they are the same answers. So I mentioned in the video that if a quadratic is factorable, that the preferred strategy is to factor it because it is cleaner. And I think I put the word cleaner in quotation marks or something. And I think looking at it side by side, you can see that, yes, it is cleaner. Does the factoring involve more thinking because you've got to go through this process and navigate the algebraic thinking in this property? Yes. Quadratic formula is very autopilot. You just identify A, B, and C, plug the numbers in, and call it a day. But lots of steps, lots of places for arithmetic mistake. It will land you at the same spot. Sometimes you have to use the quadratic formula. Sometimes factoring is simply not an option that you have. But you can definitely see that this is a cleaner strategy. It runs better from top to bottom, even if you put the scratch work in there. Okay, so that's a good comparison, contrast, and a nice refresher on that quadratic formula. All right, and for these ones, the question is just determine if the quadratic is factorable. One of the tips I gave in the video is if you are unable to get the factors fairly quickly, double check and make sure that it actually is factorable in the first place, okay? That is, we don't want to spend a lot of time on stuff that's not factorable. So the way we determine if something is factorable is we check that piece of the quadratic formula. So that piece, okay, it's called the discriminant, and it's the piece underneath. the square root. It's the b squared minus 4ac, and it tells us stuff about the answers. If in the quadratic formula, you get to a spot where you can take the square root, like we just saw the square root of 121, and we get an integer, okay, that means it is factorable. If you get to something and you can't take the square root, it means it's not factorable. Stop trying. So in this first one, we have, what would be nice is if I turn my pen on. There we go. We have a is equal to 3, b is equal to -2, that's a negative, and c is equal to 4. So we're going to have -2 all squared minus 4 times 3 times 4. This will be 4, and then I almost don't care. I've got, 12 times 4, 4 minus 48, and at this point, like, I'm just going to say that's negative. Okay, like I don't even care what it is because I've gotten all the information I needed out of this. You might even be able to see it from here. Okay, 4 minus something bigger than 4. You don't even have to do it. It's going to be negative. It is going to be -44. Okay, but we don't even care about that. Negative, and what that means is that is not factorable. Okay, and just so you can see a little bit more, like, I know you're in this for a practice set, but just so you can see, okay? So you do 3 times 4 is 12, and then you go and get all the pairs that multiply to 12, and you're looking for something that adds up to -2, and there is nothing. There is no factor pair of that would add up to -2. And so like you can't get a 2 from those. So that is not factorable. And what can happen is if you've got bigger numbers, or you tend to miss pairs, or you think, oh, I should have come up with a number, like it's possible that the number pair doesn't exist. So your discriminant can be a way of checking that. Like just make sure that whatever you're factoring is something that actually can be factored. Now 10, we need to do a little bit of work with this. So in order to check the discriminant, we do need to get a 0 on one side. It actually does not matter which side you get the 0 on. So in this case, if you wanted to subtract the x squared from both sides and get -x squared plus 2x plus 15, that actually would work fine. Or you could move the stuff over to the other side and do this x squared minus 2x minus 15 equals 0. Either one of those would work. I don't recommend factoring with a negative leading coefficient. Like I would not factor it this way. I would factor it this way. So you might want to go with this way, just if it is factorable. Now it's in the form to factor it, but you can check it either way. So let's go ahead and check it. So we'll do this one over here just for fun. A is -1, B is 2, C is 15. And we're going to check b squared minus 4ac. So that's going to be 2 squared minus 4 times -1 times 15. And it might help right here to think of that as plus -4. So this will be 4 plus, and then 4 times -1, or -4 times -1 is +4, and 4 times 15 is 60, and 4 plus 60 is 64, and that is a perfect square because when you do the quadratic formula, you would get an 8. So that is factorable. And just because somebody doesn't believe me, okay, so A equals 1, B equals -2, C equals -15, you're like, why it shouldn't matter? Now let's go double check. -2 squared minus 4 times 1 times -15. And then we'll change this over to the plus negative. -2 times -2 is +4. -4 times 1 is -4, and -4 times -15 is +60, and you end up in the same place. So just pick whatever you want, but that is factorable. All right, another long video. These problems just take a lot of explanation. There's a lot of little details to get into with them where, yeah, just like look at this, consider this. But hopefully this was helpful to you. Hopefully you got a nice review of solving them and saw some things and some connections with some other ideas. If you did, please give it a like, subscribe to the channel, drop a comment or ask a question to engage, and check out the other videos on the channel. I will link the video on using the quadratic formula, maybe here, okay? And I'll link something else down there, who knows, but go ahead and check it out, okay? And I will see you in the next one.